Hi, I'm Whitney Espich, the CEO of the MIT Alumni Association, and I hope you enjoy this digital production created for alumni and friends like you.
Well, often when you see talks from MIT people, they deal with what we can do. In this session, we're going to address what we must do and will do. Hi, everybody. I'm Maria Zuber, Vice President for Research, and I hope you're having a great tech day. Welcome to the session on what MIT is doing now and what we're going to be doing in the future with regard to climate change. So I'm going to start sharing my screen here as I'm talking. Okay, well, today you're going to be hearing from some of the faculty who are leading the charge on this issue. And a bit later, we'll be answering your questions as well. So please submit any questions that you have for us using the Q&A tool on the streaming page. And you can also upvote others that you'd like to hear answered by clicking on the thumbs down or thumbs up icon next to your favorites. But first, as the person that President Reif has asked to oversee MIT's response to the climate crisis, I would like to share my own perspectives with you. All right, so this is the only graph that I'm going to show today, but it's an important one. So the reddish area that you see at the top, let's see, we're plotting gigatons of greenhouse gas emissions on the ordinate and time on the abscissa, so you can all follow that. Now, the reddish area there shows the Earth's atmosphere would warm by between 4.1 and 4.8 degrees Celsius by the year 2100 if the world continues to emit greenhouse gases at the rate that we've been going for the last several decades. The great majority of scientists believe that this would be a disaster for humans and for many of the species with whom we share our planet. The good news is, I don't think this is going to happen. Humanity is finally waking up to the risks, dangers, and costs of a business as usual approach to energy, and some promising changes are underway that should bend this curve downward. But the bad news, that is, it is not clear at all whether we're going to make enough changes as quickly as we need to in order to head off a future that is just slightly less disastrous. As many of you know, back in 2015, when MIT adopted its first climate action plan, 192 nations met in Paris at the UN Climate Conference and made initial commitments to cut their greenhouse gas emissions. That's shown in yellow under the pledges. Now, I was privileged to be representing MIT at that conference, and it was a time of excitement and hope. However, those initial commitments were not binding, and in any event would not be enough to avoid some very bad outcomes. Policies currently in place around the world would get us down to about 3 degrees Celsius, and if countries all kept to their current pledges, we might get as low as 2.5 degrees. But that's still nowhere near good enough. 3 years ago, the UN's Intergovernmental Panel on Climate Change, reflecting on the work of hundreds of the world's leading climate scientists, issued a dire warning. We must keep the planet from warming more than 2 degrees Celsius, and we need to make determined efforts to keep that warming below 1.5 degrees. So our work is cut out for us. Well, we've all been witnesses to this building catastrophe. Over just the last few years, Colorado and California, which is pictured on the left, have suffered historic wildfires. Serious storms and flooding have increased. And just a few months ago, a winter storm knocked out power, heat, and water for millions in Texas. The bright side of this is that more and more people are recognizing climate change as a crisis, and climate finally has our attention. But obviously, This is not hypothetical anymore. The effects are upon us, and we have no time to lose. Now, I hope most or all of you were watching the session just before us, and you might have heard President Rife outlining a strategy for the world to overcome climate change. Succeeding at this, quite possibly the challenge of the century, requires humanity to do three fundamental things. First, go as far as we can, as fast as we can to reduce emissions with the tools that we have now. Second, invest in and invent a suite of new tools because we don't yet have everything we need. And third, train and empower the next generation, the young people who are inheriting the world, the ones who will take the baton from us and complete the race to solve the problem. Well, the climate crisis is real, it's here now, and it's deeply disturbing. We all wish this wasn't happening. However, it also provides all of us, and MIT in particular, with an opportunity to seize this moment and help the world solve the climate crisis. MIT is committed to doing this, and I am confident that we can. We need to spark the discoveries, innovations, and inventions that we need, inspire our community with a single vision that distinguishes us, continue to attract the very best talent, and fulfill MIT's mission to advance knowledge and educate students to best serve the world. A few weeks ago, we released our climate plan for the decade, which we call Fast Forward. Leading up to the plan, we spent about a year and a half of consulting and listening, and many of the plan's action items came about thanks to suggestions from the community and probably from some of you in the audience today. In just a few moments, you'll be hearing from some of the exciting things we're going to do under the plan, and you can check out the plan for yourself on MIT's climate portal, climate.mit.edu. But the most important thing to take away from today is this. MIT's climate plan is a plan for the world, not just a plan for MIT. Most universities' climate plans are about how they are going to reduce their own carbon footprint. And that's important, and our plan does that too. But MIT's plan is primarily outward facing. Our plan is designed to do nothing less than to help the world solve the problem of climate change. We can't afford to delay, and we cannot afford to get this wrong. So let's get started. As I said a few minutes ago, the world needs to both deploy existing tools and to develop new ones. And what you're seeing here is an example of both. Wind turbines might still feel kind of modern and cutting edge, but windmills have been around for centuries, and humans have been harnessing wind power for literally thousands of years. The biggest barrier to making broader use of wind power is that it's here one moment, gone the next. You can't put it in your gas tank or your furnace. Solar energy is similar. As anyone who has spent any length of time in Cambridge knows, you can't count on the sun always shining, even on summer days. Wind and solar power are proven technologies, but to maximize their impacts, we need to develop new, reliable, cost-effective ways of storing renewable energy so that it's there for us when the wind isn't blowing or the sun isn't shining. What you see pictured here beneath the windmills are batteries that are designed to store wind power so it can be used hours or days after it's collected. Improved storage and the use of renewable energy is one of the problems being explored by the new Climate Grand Challenges initiative that President Rife spoke about. Let me give you a few other examples of grand challenges. Finding new alternatives to fossil fuels, which are major sources of carbon dioxide emissions. Developing technologies to capture carbon so it doesn't build up in the Earth's atmosphere. And devising public policies that can speed up these new technologies, as well as finding ways to adapt to the climate changes that are already underway. These are the kinds of high priority problems Climate Grand Challenges is designed to help solve. Dozens of our faculty are working right now to come up with solutions to problems like these, and we anticipate providing major funding for a select few of our research teams early in 2022. Another exciting new program is MIT Energy Initiative's new Future Energy Systems Center. Our energy initiative, MIGHTY, is the focal point for a wide range of MIT's energy research. The new center's goal is to foster and inform interdisciplinary research through energy systems analysis, not just to examine individual technologies or applications, but to provide a systematic means of analyzing the global energy systems that need to change rapidly if humanity is going to win the race against changing climate. In a few minutes, I'll be introducing you to some of our faculty who are doing important work on both accelerating the deployment of existing technologies and developing new ones. But first, I want to tell you about a couple of other aspects of our plan. Okay, now, not all of the innovations that the world needs are in science and technology. While that might be what MIT is best known for, we also have a great deal to contribute to the world's efforts to design and implement programs and policies that will increase the pace of change and ensure that such changes are just and equitable. There's more to talk about here than we have time for today, but let me just touch on a few examples of the kind of work that MIT is doing in the policy front on climate change. So here in the upper left, first of all, climate simulations and models. The Earth's climate is very complex, but so is the global economy. And making intelligent public policies is going to require sophisticated understanding of their interactions. MIT is skilled at producing models and simulations that make the complexities understandable and allow decision makers and citizens to consider various scenarios and trade-offs. Now, down in the bottom left, climate-related financial disclosures. You probably saw that just last week, shareholders at two major fossil fuel companies are raising questions about what effect the changing climate will have on the value of their investments in these companies. One driver for a more rapid transition to decarbonized energy will be investors moving their capital away from these companies whose businesses are most at risk from climate change. The key here is for markets to have more and better information about these risks. We have undertaken research in this field previously, and we're committed to doing more under our plan. Now, up in the top right there, just transition challenges. Many economic transitions create winners and losers, both short and long term. Those people, communities, industries, and nations that are most at risk from the transition away from the traditional fuels that resist change, and they may have the political clout to slow it down or even stop it. Now, I grew up in Pennsylvania coal country, and my grandfathers were both miners, so I have seen this firsthand. We need to help policymakers chart a path to a low carbon economy in a way that promotes high quality job growth, minimizes worker and community dislocation, and harnesses the benefits of new technologies for regional economic development. And finally, most of the economic growth over the last several decades is expected to be in the developing world. Unless we find ways to meet the rising energy demand with sustainable fuel sources, the buildup of greenhouse gases in the atmosphere is going to worsen even as the developed world decarbonizes. So this photo down in the lower right-hand corner was taken at a construction site for a Chinese financed Port City, Colombo development on the island of Sri Lanka. Now, research on issues like these is going on throughout the Institute, at Sloan, in architecture and planning, in the Center for Energy and Environmental Policy Research, at the Joint Program for the Science and Policy of Global Change, just to name a few. There is so much more to say about our work in this area, but there are many ways that we can learn more. Okay. Well, what you see here is one of MIT's newest buildings, the Nano Building. And even as we put our resources at the service of the world to solve climate change, as I noted, we need to continue to use our own campus as a test bed for materials, methods, and practices that can reduce our own impacts and yield lessons that others can use as well. So our Nano building opened in 2018, and because of the kind of research that goes on there, tiny vibrations and changes in airflow can ruin complex experiments. We need large airflow to keep things steady, and so the building consumes a lot more energy than most campus buildings. And this was only one of several new buildings that have gone up in campus over the last few years. And I hope that next year, many of you can return to campus and see many of the exciting changes that have occurred on the buildings on our campus. Even with the growth of our campus, though, MIT's net greenhouse gas emissions have declined by about a quarter since we started working on our footprint back in 2015. Some of this has come about thanks to offsetting our emissions and reductions achieved from our financing of a 600-acre solar farm in North Carolina, but our direct emissions are down as well. And in our new plan, we're committing to achieving a carbon neutral campus by 2026. A lot of these further reductions will come about thanks to new power purchase agreements for solar, wind, and wind facilities around the country. And helping to build these new facilities also has the advantages of allowing older and dirtier power plants to be retired. But we're also committed to continue reducing our own direct impacts on campus. And we're going to do this by beginning to replace all of our gas-powered cars and shuttle buses, increasing our on-campus EV charging stations threefold and our solar panels fivefold, beginning to decarbonize our direct investments, and immediately including developing all-electric buildings at the Volpe development site on Broadway, and preparing a roadmap for how MIT will have zero direct emissions by 2050. Now, but what is arguably the most important thing we're going to do is educate a new generation of climate, energy, and policy innovators and involved citizens. A few thousand new students, undergraduate and graduate, come to MIT every year, and they, along with our faculty, are our greatest resource. And best of all, they become MIT alumni. The investments we make in our students are going to pay dividends for them and for humanity for many decades to come. Our theme, as we've heard repeatedly as we were putting together the new climate plan, was the students' desire to learn more and make a difference on climate sustainability. MIT already has world-class curricular offerings in climate science, clean energy, sustainable materials, and environmental policy, but we can do more. We're committing to provide funded climate or clean energy research, experiential learning opportunities for every undergraduate who wants one. We're creating a sustainability policy hub to find, create, and make available to students more hands-on opportunities to make a difference. We're designing environmental sustainability as a fundamental principle of design and infusing it in all relevant courses and programs. Sustainability needs to be considered just as fundamental as beauty, efficiency, and safety. And we're establishing a climate education task force to survey the field of climate-related education at MIT and elsewhere, and develop recommendations to further improve these offerings. So I hope you will go onto MIT's climate portal and spend some time exploring our new plan. You can find it at climate.mit.edu. And if you have reactions to the plan or ideas for how we can improve or build upon it, please send them to us at climate@mit.edu. There's a couple more things I need to tell you, but I'm going to do that after the questions. And also, we're going to be opening things up for your questions. Again, submit your questions through the Q&A tool on this streaming page. But first, I want you to hear from a few of my faculty colleagues about some work they have underway with important implications for the climate program. You're going to hear from Ann White, head of the Department of Nuclear Science and Engineering. She's going to tell you about some exciting developments in nuclear energy that represent grand challenges, including MIT's efforts to realize the promise of nuclear fusion as an energy source. But first, I want you to meet Jeff Grossman and Elsa Olivetti. Jeff is head of material science and engineering, and Elsa is an associate professor in that department. And they are going to tell you about MIT's new Climate and Energy Sustainability Consortium and its role in propelling climate change solutions through the global economy.
So today, Jeff and I are going to tell you the story of the coolest thing we've each gotten to help build and be a part of at MIT so far. And that is saying a whole lot, because Jeff here does research to make new materials for all kinds of applications, like those that mimic a camel's fur to keep cool, which is, and I completely intend the pun here, just very cool. Or how about the fact that he has two amazing new spinouts? One of them is making membranes out of graphene, which is only a single atom thick. And they've already put those membranes to the test in pulp and paper production, where they've shown a 90% reduction in the amount of energy used. And that idea went from first research dollar to full pilot in less than 9 years, which is completely insane.
Okay. But the thing is, the same goes for you, my friend. Elsa over here teaches computers how to read journal articles, which it turns out has completely changed our field of material science and engineering. Because of her research, computers now routinely read millions and millions of articles and then find important insights across all of that data in order to help us make better, cheaper, and easier to synthesize materials.
But we digress. As we were saying, we're both ridiculously excited about this new effort. But before we tell you anything, here's the trade we're asking for. We expect your participation. We really want you to leave with notes and thoughts to spread out into the world, especially now that the world has begun to open up as vaccination numbers continue to climb. Hooray for science, right? We want your first trip to be to Cambridge to meet with us in our new space over in Kendall Square by MIT's new innovation center that will open this fall, to hear about what we're up to and to show us the cool little threads of climate action with industry partners that you are going to write on the back of the scrap paper you just found.
So here's our first ask of you all. Think of one fact that you know about climate change and drop it in the chat. What is it that scares you about climate change? What seems like an opportunity about climate change? Or what about it keeps you up at night? I'll tell you what, I'm going to do one just to get us started. Here's my fact. It's estimated that not doing anything at all about climate, so just humming along as we've been doing, that this inaction will cost us more than $50 trillion over just the next few decades.
And so what we're saying is that we actually want you in this conversation with us. Please go grab some paper. Please join our brainstorm today. We need your help. And I'm going to tell you the fact that's keeping me up just this week. So airline emissions of CO2 are expected to more than triple by 2050. I'm going to drop that in the chat. And a little more detail, Neste, the world's largest producer of renewable jet fuel, wants to scale annual production by enough volume to fuel the equivalent of close to 40,000 flights between New York and London by 2023. That may sound amazing, but it is nowhere near enough. That needs to be scaled by another 30-fold, or almost 2 orders of magnitude, to reach just the fuel used by the US airlines in 2019. We have got to get cracking. And again, pun entirely intended.
And that really is quite a motivating fact, Elsa.
Thank you, Jeff. I do my best.
Well, and so that, my friend, is always enough. And that's kind of the point, actually, that I wanted to make next anyway. See, the thing is that companies are making commitments. They're making commitments like we've never seen before. And they're actually really serious about it. But how do they get, how they actually get there, how they actually achieve these commitments, that's not so clear. How exactly will these companies do their best, right? So on January 1st of this year, Fortune.com ran a piece titled 2020 was the year of the net zero by 2050 commitment. And in that piece, they discussed that 60% of Fortune 500 companies have set a climate or energy related commitment. And that's a really big deal. But while 2020 was the year for climate commitments, Forbes then went on to ask, will 2021 be the year we get the details? So these companies have set these goals and have huge momentum. And I would even say that a tipping point has occurred. But the challenge is they don't know how to do it. Now, just as an analogy, let's suppose I want to run a marathon, right? I can want to run a marathon. I can even commit to running a marathon. But if I don't train for it, and if I don't know how to train for it, well, I might not even make it through the whole race. And the thing is, we don't have time to not make it through. There's no do-overs here. We have to get this right, and we have to get this right now. So that very same month that Forbes ran the piece, we launched our new consortium. Will 2021 be the year we get the details? Well, with this new consortium, we believe that MIT has an opportunity to make the answer to that question just a little bit more yes.
So I like the analogy, but let's get to the point. MIT's new climate consortium, which is called the MIT Climate and Sustainability Consortium, launched at the end of January of this year. So Jeff and I have got about 5 minutes of work under our belts with the awesome folks we've gotten to work with. We've got this specific goal to help companies work together to reach these audacious climate goals, to run these marathons. Given the unprecedented urgency and scale and speed needed for this transition that Maria just talked about, they must do so not just with planning and road mapping, but with action, with execution, with problem solving. They need to test these roadmaps. They need to take bold, decisive, accountable steps to redefine business models and make change at a scale they never have before. And you might have guessed our punchline, what we're saying. These companies want to do so with MIT.
And let me just clarify one thing. It has been a short time, but not 5 minutes. It's been 5 months, but it's still a very short amount of time. But it's the right point, Elsa. And here's the thing. What's so cool about the action and the execution and the problem solving that we're doing, to me, is who we're doing it with on the industry side. At this amazing table of MIT, the consortium has convened leaders across broad sectors of the global economy. These companies are going to invest trillions of dollars to meet their aggressive climate goals. But working together in new ways, we're going to help make those investments count more. So actually, speaking of our member companies, I'm dropping a link into the chat right now that gives you the current list of member companies in the consortium. And I have another question for all of you. So I just said that we want to represent the global economy so we can find as many and the right links to accelerate our pace of change and show what that change can look like with as much impact as possible. Now, during this first year, we've gathered with purpose this inaugural set of members. And by the way, just these 13 companies, they represent 1% of global GDP. Yeah, but the thing is, it's not just their brand and scale. There's also a strategy. There's also a strategy that's important to point out. So if you take a look at the list, you'll see that in food and beverage, we've got PepsiCo, but not that other one that starts with a C. We've got Apple, but not a second company that makes those little screens you have in your pocket. And for the way in which those screens share data, we've got Verizon. Now, all of this is by design, since as we launch this new effort, it lowers the barriers to collaboration and consensus building. And another thing about these companies is the way in which they've committed, not just with a press release, but with some serious weight behind the commitment. They've elevated the importance of this topic within their own organizations, with a C-level person who reports to the CEO in charge of large teams working on climate sustainability. And I can say without a doubt that in just 5 months of working with them, these companies are ready to roll up their sleeves and work together. So given all of that, and maybe building on whatever you listed earlier in our first ask about climate, who do you think is missing from this list? Who should we engage right now?
We really do want to hear your input now, or if something strikes you later, send us an email. I'm going to add one of my own, Jeff. I really wish we had a financial institution at the table, something that Maria mentioned earlier. And this company side is obviously incredibly important, but there are new efforts starting like this all around the world. Organizations coming together, people of all kinds and disciplines. But what we are really excited about, what we get to do that's different, is we get to engage the MIT brain, which, as you guys know, is really good at solving very hard problems. But we need the entire MIT brain. So we really are truly a cross MIT initiative. We have a 12-member faculty steering committee that has representation from 11 departments across all 5 schools. We have deep engagement to amplify and extend existing centers, some of which Maria just mentioned, such as the MIT Energy Initiative, Joint Program on Global Change, Environmental Solutions Initiative, and of course there are others. But by working across the Institute in a really deep way, we really want to demonstrate the scaled benefit of intelligent and material product design, efforts that make concerted investment in technology and information for tracing of materials and products throughout entire value chains, identifying key leverage points for policy, making significant opportunities for underserved communities, and really addressing tough sectors to decarbonize. We really want to work collaboratively to identify the crux of implementation challenges to set the stage for equitable environmental innovation that's linked to solutions across technologies, business models, and including the critical human aspect, as those are the agents of real change, all of us. But this is linked with highly complex interdisciplinary system design, which I get really excited about.
Well, you know, actually, Elsa, I get really excited hearing you talk like that. I mean, it just makes me incredibly excited to be able to do this at MIT and with, as you call it, the MIT brain. And by the way, that includes every single one of you out there in the audience. The thing is that the complexity of the design space of climate sustainability and the deep interconnectedness of it all, we need to be able to hold all of it in the same room. And if there's anywhere in the world and any set of students and faculty and staff and alumni who can take this complexity on, it's going to be MIT. That's the vision that our Dean Ananta Chandrakasan had when he thought to start this effort last summer, that it would be cross-economy, cross-institute, and with the goal of defining accelerated ways to translate brilliant MIT solutions into practice.
So because the companies that have joined us are large and make up more than 1% of the global economy, as Jeff said, they bring to the table a surprising set of opportunities. So the conservative sectors or aspects within a company can learn from our entrepreneurial ecosystem or from other companies where fast-moving efforts demonstrate the value of failing fast. But also companies with long histories of seeing change can help the newer industries not repeat the mistakes of the past. So take, for example, our first workshop that literally happened yesterday on sustainable supply chains and decarbonizing tough parts of transportation. So Boeing, who you might have seen if you clicked on that link, obviously plays a clear role in helping us understand the limits and opportunities in aviation transportation. But here's the cool part. PepsiCo, we might think of as food and beverage, but they also own and operate the largest independent trucking fleet in the US. And Cargill doesn't just develop agricultural products and play a critical role in carbon soil health. They also run Cargill Ocean Shipping, which is playing a major leadership role in getting the shipping industry to net zero. And IBM, that also spoke at yesterday's workshop, has extraordinary tools to help us understand how these supply chains are going to need to evolve and be resilient in the face of climate risk.
And I just have to add to that, because what we got to witness yesterday was just a tiny glimpse of why this is going to work and what wild success will look like. These companies in 90 minutes, and by the way, over Zoom no less, after hearing from each other and after hearing from 8 amazing MIT researchers on the topic, they began to discuss links on how they can work together to accelerate certification processes for biofuels. And they had a discussion on how to work together to fully optimize systems across transportation modes rather than just within a single one. So, you know, when we think to the next workshop, which is, by the way, coming just next Thursday on carbon removal using natural ecosystems, we see the same opportunities. And in that workshop, we'll have Apple. And because of their use of paper and packaging and their market presence, it means they have a huge opportunity to shift investments towards generating forest preservation and management. But that's in turn linked with Kraft, who will also present at the next workshop on their interest in paper recycling. All of these links are here at the table of MIT, and we're so excited to work on them together.
So this leads us to the final thing we really want your help with. A few minutes ago, we had the link of company members in the chat, so you can find that again. And Jeff asked who is missing. So given who's there, we want you to pick a few companies and come up with an idea of how you think they could work together on climate and sustainability, or add the organization you thought was missing, because that's what we're going to do with the outputs of these workshops. We're going to take the ideas that link across companies, where moving together offers some amazing opportunities to accelerate change, and find the best teams at MIT to take them on, mentor and learn from a cohort of postdoctoral fellows we've just launched, engage undergraduate students through a climate scholars program we're building that's linked to UROPS. The first UROPS being performed this summer already with a local member of our consortium, MathWorks. We want to pilot projects with companies, inform policy linked to the rest of the Institute's efforts. And we really want to build an alumni network that can help us source from the very best to do our very best. So while you're writing on your scrap paper that you're going to come share with us, or in the chat, or mulling over a copy in whatever time zone you're in, we want to close by Jeff and I each telling you an example of a linked opportunity that we're really excited about while you're thinking and sharing yours. We can talk more about in questions. Please keep dropping those ideas.
Oh, so this is a really hard one for me, because it's hard to just pick one thing I'm excited about. I'm excited about many, but I'll share one. One of the things I'm super excited about is the work that we get to do linking companies around carbon capture, utilization, and sequestration. So just as an example, on the one hand, you have Dow, who's developing chemicals for capture technology. Yeah, but that can be linked with LafargeHolcim, which might use those technologies on their manufacturing facilities to convert CO2 to new cements. And all of this can be optimized by IBM's advanced AI tools to accelerate materials design. And while we're at it, Accenture's footprinting tools to keep track of it all. The potential is enormous here.
So mine right now is working with Inditex on collection schemes for used textiles, where we could probably think about opportunities for startups focused on underserved communities. And that, I think, could be linked to PepsiCo's interest in bio-based polymer design that could be based on Cargill's production side streams, maybe all optimized by data-driven innovations in tracing and tracking by Nextfloor and Hockteeth. Might be getting a little bit carried away. So we certainly don't have it all worked out, which is why we need your help and have been asking for it throughout the session. We're paving the road while we drive down it, as we do at MIT, or I should probably say, we're paving the road made with recycled low CO2 cement in a fully optimized way in our 500-mile range fast charging e-vehicle to an area of afforested land where we've learned from local communities how to cultivate entrepreneurial opportunities. That was a mouthful.
That was just perfect. Look, this is what we do know. We do know that we have the incomprehensible pleasure of working with the entire MIT brain in collaboration with a broad set of deeply engaged companies, where both communities understand there is not a moment to spare to invent the ways to work together, to invent the ways to conceive and solve one of the most significant problems of our generation. So now you have a mission and a thinking exercise from us. Our next speaker also has a mission for you. So here next to talk about fission and fusion to create power and make a more sustainable world is Ann White.
Thank you so much, Elsa and Jeff. And now for everyone listening today, I ask, can you imagine a future where all the waste from your life's energy use is sequestered away, where it cannot damage the environment or lead to climate change or contribute to deaths due to air pollution? I can, and I don't just imagine it. I'm working on building it today. We can responsibly and rapidly expand the use of nuclear energy worldwide. Fission has already reliably and economically contributed to 20% of electrical generation in the United States over the past 2 decades. If I put up some recent data on nuclear electricity generation in China, the EU, the US, and the world, you can see it here as the percent share of the total energy in terawatt hours. Now I can also add up for comparison hydroelectric. And in addition, I'll put up what we get from other renewables, wind, and solar, for example. You can see from this data that fission power and hydro together already provide the majority of carbon-free electric power generation worldwide. Nuclear energy holds tremendous potential for fighting climate change, and it can do so sustainably in a manner that does not compromise the future generations' ability to meet their needs. But in order for us to be successful, we have to work now with industry partners to address their immediate needs. What you see here in the upper left is a diagram of a light water reactor, showing the system of how coolant flows from the core and the fuel rods. Now at the right-hand top photo, you see a close-up of fuel rods, and you might notice there's some buildup of some materials on there, which has been corroded from the coolant system and is now attaching to the rods. That material is affectionately in the industry called crud. Crud matters because it fouls the cladding on the surface of the fuel rods in light water reactors. And the crud accumulation obstructs heat transfer and can cause the rods to fail. If fuel rods fail, it causes unscheduled outages, which can cost a typical gigawatt electric power plant millions of dollars a year. By some estimates, that's about $12 per second. Our faculty developed new crud-resistant materials by studying the basic physics of adhesion, and they figured out how to keep crud from sticking. In just 7 years, a professor was able to take his physical insight to demonstration of a crud-resistant coating for fuel rods, shown first in the MIT reactor on campus, and then later testing it out in a commercial reactor. 7 years. That's an extremely fast development cycle for the nuclear industry. And it just shows one example of how technical innovations can rapidly support the current fleet of fission reactors, helping them to be more cost competitive, and also helping fission continue to grow as a source of carbon-free energy. But we have to think bigger than this, because decarbonizing energy use requires more than just electricity. We've got to think about industry, agriculture, transportation. We have to change the game. We have to expand nuclear energy to new markets using new innovations. The figure you see here shows greenhouse gas emissions by economic sector. You might be surprised looking at this, at the one blue wedge on the top right, that electricity and heat is really only 25% of the pie. And certainly the traditional zero carbon impact of fission energy is here in this pie, going to consumers, our homes, our schools, our businesses. But it's these other markets you see that do drive the bulk of carbon emissions. And here, fission can also play a major role. There are massive growth opportunities for nuclear, poised to happen near term within a decade. An opportunity for nuclear to supply lower cost heat in a low carbon world is pretty important. Consider that the industrial sector, that's 32% of total US energy consumption, uses mostly natural gas and petroleum for heat. Replacing that fossil fuel with nuclear heat is highly advantageous. In addition, in the transportation sector, hydrogen and low carbon alternate fuel production and combined with electrification would open new doors for nuclear power applications. One such game changer here is the microreactor, or as one of the faculty members in my department calls them, nuclear batteries. The idea would be you could fuel a nuclear battery only once every few decades, in contrast to every few years in a traditional fission plant. You can use these nuclear batteries for off-grid, mobile, containerized production and processing, revolutionizing agriculture, aquaculture, pharmaceuticals, 3D printing, and data center energy use. Co-located supply and demand nuclear batteries would be truly transformational for communities and businesses worldwide. There are many technological advancements needed to make this happen. We've got to improve cooling, think about heat transfer, discover different approaches to managing the reaction, all in order to sustain nuclear reactions in the much smaller package here compared to a conventional nuclear reactor. But despite all that, a realistic timeline for these technologies, depending on application and installation location, the reality is less than 10 years. So nuclear energy indeed has great potential as a key tool to achieve deep decarbonization across all sectors of the economy. But let's be very blunt here. Nuclear energy has a problem with public acceptance. Making the case to our friends, our neighbors, and maybe to ourselves that nuclear can and should be part of a sustainable energy future is not easy. All energy technologies have a range of adverse environmental externalities, which can differ from one technology to another in their kind and their magnitude. But nuclear is special. Because of the history of nuclear power, the potential negative aspects of nuclear are always at the top of our minds. I mean, a lot of people have HBO, right? And so we've all watched Chernobyl. And so safety is one major thing that people think about. Chernobyl involved reactors that had no containment vessels and were operated in a manner inconsistent with safety practices at the time. Faulty design and human error. Surely a horrible tragedy, made more horrible because it was preventable. But we even need to put this awful event into context. It's one of the 3 nuclear accidents that you've probably heard of: Chernobyl, 3 Mile Island, and Fukushima. In fact, over the past 70 years, there have been only these 3 serious accidents and about 10 incidents total over 7 decades. Fukushima in 2011 is, of course, the most recent accident, and it did have very significant impacts on public perception of nuclear power. As you all know, a few days after the tsunami knocked out power, a backup generator-based cooling system failed at the Fukushima Daiichi nuclear power plant, causing the reactor fuel to melt, and radiation was released. There have been no deaths or cases of sickness from the nuclear accident, but over 100,000 people were evacuated from their homes. But in fact, since then, the Fukushima prefecture has achieved a remarkable recovery thanks to extensive cleanup. Negative perception, however, still persists across Japan and the world. Rising up to this challenge, local high school students teamed up with the University of Tokyo to collect their own radiation data. Their results have shown that radiation levels in Fukushima are not at all higher than any other place in the world. And looking at this map, you see all of Japan's nuclear energy power plants along with the epicenter of that major earthquake in 2011. So again, while you probably heard about Fukushima, you didn't hear about any of the other nuclear power plants, just like you didn't hear about this amazing story of young people and their resilience. In particular, the Anagawa nuclear plant is an interesting one. Nearer to the epicenter, it withstood the historic earthquake and tsunami, and its operators were able to shut it down safely. Not only that, the Anagawa power plant's gym served for 3 months as a shelter for people made homeless by the earthquake and the tsunami. So while we very often hear about the danger of nuclear, we usually don't hear about dangers from other forms of energy. In 2017, air pollution was responsible for an estimated 5 million deaths globally. That means it contributed to 9%, nearly 1 in 10 deaths. And low-income countries are the hardest hit. But since we don't hear about it, we need to take a look at the data. So I've put up here a figure which shows the impact on human health and well-being of different forms of energy, as quantified by the death rates per unit energy produced. The reality is simple. All the low carbon sources of energy, nuclear, wind, hydro, solar, are all extremely safe. The issue with nuclear is our own natural and very human perception of danger, which often doesn't match reality. It's challenging to properly assess very low probability and potentially high consequence risks. We just don't register in our minds that nuclear is one of the safest forms of energy. But of course, after safety, nuclear waste is a valid concern. And unfortunately, the cartoon image you've seen here is what many people think nuclear waste looks like. Now, I like The Simpsons as much as anyone else, but so many in my generation grew up with this being a major part of our knowledge of nuclear. Now, the reality of waste is much more boring and less entertaining than The Simpsons. but I will do my best to make it a little exciting. Nuclear waste is spent fuel. It's a solid uranium fuel pellet about the size of a thimble. In fact, it still contains useful energy. In some countries, France, for example, spent fuel is reprocessed and recycled to be used again in power plants. So why is the amount of waste so small? It comes down to physics. When we burn wood or coal, we're releasing the potential energy that's stored in chemical bonds. And these fuel have about the same energy density as a Twinkie that our bodies can also burn for energy. But nuclear fuel is a whole other ballgame. The potential energy stored by the nuclear forces holding the atom together is hundreds of millions of times higher than what can be stored in the chemical bonds. So nuclear fuel is extremely energy dense. So coming back to the waste, I think we asked everyone to bring a soda can or your favorite drink. So if you have it, hold it up, hold it in your hand, get a feel for it. This is how much spent fuel, the dangerous high-level waste, you would produce in your lifetime if we made all your energy with nuclear power. That's it, a 12-ounce can of soda. Nuclear power makes so little waste because of those enormous energy densities. So the next time you have that soda in your hand, think about it. That's all the waste, with no carbon emissions, with no air pollutions. Now, of course, we have to store this spent fuel somewhere. It is radioactive. It can be dangerous if handled incorrectly. And if we're not going to reprocess it further and use it again, we've got to store it. So big spoiler alert, we're not going to store it in a soda can. Instead, it's stored in over-engineered vaults of soda cans, pretty big containers, taller than a typical person. But these containers are so robust that in about 60 years of civilian nuclear power production in the United States, and in many thousands of miles of transport of these kinds of containers, they've never leaked radiation to the environment, 0 times. And also, after about 60 years in the US, so 60 years of helping with carbon-free electricity production from nuclear fission, there's about 1 football field of spent fuel to show for it. That's it, for the past 60 years. I pause here because when I hear this fact, and I hear it a lot, it just doesn't register. I have to stop and somehow close my eyes and imagine this 1 football field, and then compare that to what we've done to the environment through unbridled carbon emissions from burning coal and gas. And I know it doesn't have to be this way. Nuclear can be sustainable in part because that fuel cycle results in waste that can be easily isolated from humans and from the environment. Technical solutions for impenetrable storage containers are already in hand, and we know we can place them deep underground where they remain isolated for as long as we like. Deep geologic repositories for spent fuel have been adopted in other countries, like Finland and Sweden. Onkalo is a facility in Finland, for example, shown here in this picture. These countries didn't do this overnight. It took a decade of careful partnership with local communities to communicate the benefit of nuclear and the truth about the technical solutions for managing safety and waste concerns, because these concerns are very valid. They're the concerns that all thoughtful people have, and they have to be addressed. It is possible to gain public acceptance, and this was the mission Elsa was talking about. You can be part of this, because now you can tell this story to your family and your friends. And in case you'd like to learn more, towards the end of this, we'll push in the chat to you a series of slides on the value proposition for nuclear fission, containing a lot more data to consider. And we'll also go ahead and invite you to a more technical talk on advanced nuclear in a few days on the 8th of June by my colleague, Professor Jacopo Bongiorno. But right now, there's more to the story beyond fission energy, because there's a form of nuclear that's even more energy dense and results in 0 high-level waste. So yeah, you can toss that soda can in your recycling bin because you don't need it now. Because now we're going to talk about fusion energy. The opposite process of fission, fusion combines light nuclei that are being interacted at very high energies to create heavier nuclei. This releases nuclear energy in the process. Fusion is what powers the sun and the stars. Fusion reactions of interest on Earth for clean energy production use hydrogen isotopes as fuel, and the products are a neutron and a helium nucleus. A very energetic neutron, a big energetic bouncy ball flying through, but the other product, indeed helium, that goes in a balloon. At MIT, we are actively developing this perfect energy source. Fusion relies on confining a 100 million degree plasma for a few seconds to generate net energy. But fusion is naturally zero carbon with no polluting emissions. The fuel comes from water and rocks. It's freely available with what we can calculate to be a reasonably inexhaustible fuel supply. Fusion also allows for flexible generation anywhere, and it doesn't have any risk of meltdown or long-lived waste or other concerns that fission energy has. MIT is now partnering with a startup company and with industry to build the world's first net energy fusion experiment. And we're doing this on the fastest path possible. The principle behind this experiment that you've seen here is called SPARC. And it uses super strong magnetic fields that are generated by electromagnets. And these electromagnets are used to hold those charged plasma particles in place. You can hold them in place and confine the fusion fuel long enough so enough reactions happen to generate net energy. And the other good news is this is also happening fast. Within a decade, this machine that we'll build called SPARC will demonstrate this and launch a totally new fusion industry. And the new superconducting magnets for fusion are being built by a big team of scientists and engineers in our laboratories on Albany Street at the MIT Plasma Science and Fusion Center. This is literally happening on campus right now. The future of nuclear is at MIT. And when we can welcome visitors back to campus, I know that Professor Dennis White, the director of the MIT Plasma Science and Fusion Center, would be absolutely delighted to give you a tour and show you around. So there you have it. Decarbonizing energy requires more than electricity. We have to think about industry, agriculture, transportation. Nuclear energy has great potential as a tool to achieve deep decarbonization across all sectors of the economy. And nuclear energy and sustainability are not incompatible. There are ways to expand nuclear energy use that do not compromise the ability of future generations to meet their own needs. I know I've covered a lot of detail in 20 minutes, but you're all champs. You should give yourself a round of applause after the speed talk here, because now you know the story of how we can expand the use of nuclear energy wisely. And I do hope to see you all someday back on campus where we can talk more about the amazing research happening at MIT as we rapidly push towards a sustainable future.
Okay, Anne, thank you. And Jeff and Elsa, thank you very much. So now we've got some questions coming into us here, and let's see. The first one I think we broadcast out to all of you, so we might as well ask it. If we can agree that the climate crisis cannot be separated from economics and especially finance, what's necessary to change the focus of education in those fields to support mitigation goals? Okay, so that's one. I think I'll start with that one, and then the rest of you can be thinking about whether or not you want to add to it. So, so that goes a little bit to what I mentioned in my talk about financial disclosures. So if a company isn't being sufficiently transparent about what its climate risk is, then obviously it's not possible for investors to do a fair evaluation of it. So investors if the information isn't going to be provided, investors are going to think for themselves what those risks are. The other thing that I'll say here is carbon intensive companies, there are cases emerging where they're just shedding the carbon intensive parts of their businesses and then still using them. So, so for example, you know, a part of an oil operation that has the flaring associated with it, a company could spin that off But doing that would reduce ostensibly the climate risk of the company and the carbon footprint and the accounting. But we haven't actually reduced the carbon dioxide that's going into the atmosphere. And so that's why there is a push now on having companies report Scope 3 emissions, which are emissions that your vendors and suppliers are using. So if you're still making use of that asset, even though you don't own it, it's still on you. So that's, that's one of the things that I think could happen. Do any of the rest of you have another comment on that, or should we go to another question?
Maria, maybe I could just add one quick thing on the student experience to that. I think it's a really great question. One of the things that we're working on in the consortium that Elsa mentioned is this 1 year sort of focused undergraduate experience that students can have. It's like a super URAP program, but dedicated to climate sustainability. And in that is an experience where they get to work directly with these member companies, maybe multiple member companies, in order to understand what translation means, right? And I mean, there's this transition that the world has to make at a planetary scale, right? But in order for that transition to happen, translation has to happen. Translation from ideas and innovation into practice. And it has to cross all the boundaries, right? It has to include all the schools and the new college, right? And it needs to happen faster than ever before. And as we talked about, we have to tackle a more complicated problem than we've ever solved before. But getting those students in a kind of cohesive way, working together with companies who are doing that, translation at scale, will, I think, really help in their education and in their ability to make an impact faster.
Great. Okay. Thanks, Jeff. So let's take another one, because we've got a number of them here. And let's see. So Anne, I think this one was ready-made for you. How important is the rapid development of current very, very safe nuclear fission power plants to supplement wind and solar to provide consistent electricity across the US?
Yeah, thank you. That's a really, really thoughtful question, is how can these be made to work together? And I think the answer is we know technically how to do it. And this question is more about why. What's interesting to this question, what's interesting is to think about sort of an uncontrolled experiment that has already happened. Post Fukushima, Germany opted to decommission their power plants. And in fact, what happened in that country is emissions spiked. Furthermore, a lot of studies have been looking at what would happen if you were to replace nuclear with wind and solar, say in Sweden, for example. And those studies also show that greenhouse gas emissions really go up. So it's important for us to deploy all the tools we have together, to combine nuclear and to combine it with wind and solar to really make rapid progress on reducing emissions. And we're well positioned to do that. So it's a great question.
Great. Okay, thank you. Let's see. Here's one on carbon capture. So does carbon capture, whether at power plants or from the atmosphere, have the potential to have a serious impact on global warming? So let's see. Let me start with. I'll throw something out on that one, and then if anybody else wants to add something. So first of all, carbon capture is likely to be exceedingly important. I mean, you at the beginning of my talk, all of you saw what the increasing carbon emissions looked like as places in the developing world are now seeking energy to improve their lives. And they're going to take the cheapest energy they can find, which is why we need to make low carbon, zero carbon energy cost effective. But many, if not most of the simulations that take into account future growth and needs indicate that we're actually going to have to remove CO2 and other greenhouse gases from the atmosphere if we're going to want to, if we're going to be able to stay below 2 degrees C. So carbon capture is absolutely going to have to be a part of the solution to that problem. Now, the issue now is there are methods that do it. They are not cost effective. And, you know, as we've said a number of times here already, economics matters. I don't know, Jeff or Elsa, you know, who are the material scientists, if you want to comment on anything more associated with that, say on the technology side.
Sure, I'll offer the opportunity. There's the workshop that or symposium that Mighty is hosting this week that is looking just at that topic amongst a suite of other carbon removal approaches. And so we'll push the link for that. So there'll be lots of detail on the technology. And, you know, that's another way that the consortium is trying to work to kind of link with the companies they're working with and, you know, what would their interest be. So particularly speaking to the technology, Maria, but I think there's lots of opportunities for folks to learn in more detail there. And I'll just underscore that I think, you know, it has to be part of the solution. There is this mismatch in scale, right? As the sort of significant sources of carbon and what we then intend to do with it and, you know, drive, you know, value added products from that still needs a lot of deep thinking in a rapid way. So I encourage folks to go to the symposium to learn more of that Mighty's hosting.
Great. And I'll just add one more thing. Of the 28 finalists that we have on Grand Challenges, you know, I think close to a third of them dealt with some aspect of the carbon capture problem. So it really clearly has captured the imagination of our faculty and students on campus as the real need for development in this area. So let's see if we can find another one here. Okay, Jeff, here's one that should be of interest to you, given because it relates to your own research. So what's being done on ways to extract energy from coal without burning it and emitting CO2? This is something that I know is of huge interest to you. So.
Yeah, thanks for that question. It does speak very closely to my heart in terms of what we do in my own research group. Because so coal, it turns out, is this really messy material, and all we do right now is essentially just light it on fire. But the way I see it as a material scientist and engineer is it's got all this like precious kind of carbon chemistry inside of it. And so this is not a new idea to understand sort of, how could you extract that chemistry and make products out of it, right? But the challenge is that it's been too hard to do historically because of the energy inputs that it takes to do the extraction. But this is a new era of materials design, right? And so this is a new age where we really can actually, work with this level of complexity in scalable ways, right? And so, actually one of my colleagues in our department, Don Sadaway, says if you want to make something dirt cheap, make it out of dirt, hopefully locally sourced. And, coal is just about as cheap as dirt. And I think we're not really, what I'd like to do is offer other markets that are more valuable in terms of making it into products. And I'll say one more thing, which is that is related to a broader point, right? Which is, what are you going to do with all the CO2 that we're going to capture, right? So we need to also understand the chemistry underneath that and how to make materials out of that carbon, as well as a whole bunch of other carbon streams that we hope to be having a lot of in the very near future.
Yeah, well, thanks for that, Jeff. And I'd also throw in here that we've got another faculty member, Mark Goldthorpe, who's actually looking how to build housing from carbon materials. So if we have something that we don't want to emit and we find a use for it, then it's a double win for us. Okay. Let's see. Here's a fusion question for you, Anne. Why is Spark more likely to succeed than all the past 50 to 60 years of fusion research? So that's a softball for you, I know, but
But it's a really smart question, right? Because everyone knows, wow, we've been doing fusion so long and it's always 20, 30 years away. So what's really different? What's fascinating about Spark is that it is built on those 50 years of an established science basis of plasma physics and how confinement and transport work in one particular type of magnetic bottle called a tokamak. So the physics basis for tokamaks is so well established that it's not just the path MIT sees going forward, it's the path that the entire nation sees going forward in building a fusion pilot plant. This is what has come out of the National Academies of Sciences, as well as the Fusion Energy Sciences Advisory Committee. So what's new about Spark then? If it's not new physics, if it's using all established physics, it's the leap you can make because of the technology, because of the engineering. It relies on taking tokamak physics to the obvious next step of operating at very, very high magnetic fields, which wasn't possible a few years ago because there weren't the right kind of superconducting materials available. Now those materials are available from industry. They can be purchased in very large quantities, and they can be used to actually build the electromagnets for Spark. So the answer is quick: establish physics and then taking a great big leap because of innovations in technology. What's more MIT than that?
Yeah, if I could just add to that, Anne, the magnets that really represent the technological leap here, they are based on they're the technological manifestation of a discovery that was awarded the Nobel Prize in Physics for low temperature superconductors in the 1980s. And it was only recently that the technology has advanced to be able to realize that and turn it into a device that can be used. So it's not the only technological advance that we need to make fusion a reality, as you've laid out. But it was, I think we all agree, it was the tall pole, and so more to come on that. Thank you. Let's see. Well, here's a question. I guess this one is for me. On the political environment in the United States. My biggest concern is that there is still a lack of political will in many parts of the country to vote in the politicians who will make the policy changes necessary to solve climate change. Okay, so this obviously, right now the politics in the country is very divisive, and there's a large reliance on ideology as opposed to practicality. And whatever your politics is, I think we can all agree that the divisiveness isn't doing any of us any good. However, things are changing with regard to the way that the U.S. population is viewing climate change. So the number of the polling indicates that the number of individuals who think climate change is a problem is growing. Communities are being affected by it, and so the politics is going to continue to be problematic. However, we can do a lot at local levels. We can come up with solutions. And one of the things that MIT has been working on, and this is in the really on the policy side of things, is going out to local communities that have been impacted by the transition. So what I often say is the problem isn't climate and understanding the climate is a problem. The real problem is that we have a transition in jobs that's underway, and we have to deal with that to be able to deal with the problem in climate. So we've actually sent teams out to local communities that have been impacted to try to work with them to try to find ways that we can have an economic transition. And if new jobs are being created in the zero carbon energy industry, and those jobs are not going to people whose jobs have been displaced by carbon intensive industry, then we're going to have a problem. So, so more and more of that has to happen. And I'll just, one last thing I'll say here is we're working a lot with who can be the effective messenger to these affected communities. And so it usually isn't a scientist from MIT, and it most often is a community leader, a religious leader, people that the people in those communities know and trust. And so really trying to work with them and educate those people to give them the information that they need, and then to work with them to try to find solutions. So, okay, what else have we got here? All right, Elsa and Jeff, I think this one's for you. Given that utilities, primarily electric and gas, are players in fossil fuel use reduction and are interested in climate change, it's interesting to see that there aren't any on the list. So is there a reason for not including those?
Sure, I'll take this one, and then Jeff can offer thoughts as well. You know, the sort of strategy that Jeff laid out in terms of how we engaged the companies that we wanted to begin the consortium with has this sort of embodied supply chain aspect of it, right? The kind of tough to decarbonize sectors that are proximate to energy producers, energy distributors. This was because we want to work in close concert with the Energy Initiative. The Energy Initiative also works outside of energy producers and energy distributors. They have a very broad reach. But the sort of center of mass of Mighty has been in the, or, you know, has had company partners in that space, more so than the PepsiCos. So not exclusively, but just as an opportunity. So we thought that part of who we engage with, if we think about the sort of maybe consumer facing aspects of the global economy, that might be a way to start to build ways to amplify and extend all the wonderful efforts going on campus already, for example, at Mighty, you know, in a way that helps transition all of the economy. So it was a bit about this strategy that Jeff outlined when we were talking before, in terms of where we felt like there was an opportunity really on campus.
Yeah, Elsa, could you, or maybe we'll toss this one over to Jeff, build on what you said right there and talk about the potential for collaborations of industries that are working with other parts of MIT to get into this conversation.
That's a great question from the audience and from you, Maria. I think just building on what Elsa just said, you know, when we started thinking about this last fall, you know, the very first thing we did is meet with the leadership and people of all the organizations thinking about this problem across the Institute, because, you know, what we want to be is as you know, these words amplify and extend are really important to us. They are part of our mission. What we want to do is amplify already ongoing projects, already ongoing work, and extend those through the work that we can do with our member companies. What we don't want to do is duplicate, because again, you know, we want to be as efficient as possible in the work that we do. So if we have, for example, partnerships that we can form, then we want to leverage those and we want to enhance those and we want to bring the right people together in the room, as opposed to duplicating them. So I think, you know, building this this effort together and working together is a critical part of what we're doing and of Maria's vision. And so we're very excited to be a part of that.
Yeah, and I'll just add, you know, we want to make it easy for the companies to engage too. You know, it's easier for a company to have a portal into MIT and then to, you know, engage broadly than for a company to have to come into MIT many different ways, because that often means many different negotiated agreements, and it just gets complex. So so we're all for simplicity and collaboration to make progress. Okay, we've got a question here on the campus. What specific steps is MIT taking to get to net zero emissions? as soon as possible. So, as I mentioned, albeit very briefly in my talk, we've indicated that we're going to get to net zero by 2026, but this is going to be through a combination of reducing emissions on the campus, as well as engaging in power purchase agreements that essentially involve offsets. But again, looking to partner with other organizations to bring benefits there too. And the advantages of these power purchase agreements is that we often wind up replacing very carbon intensive power generation with something that's zero carbon. So for example, our solar farm in North Carolina led to the decommissioning of a coal-fired power plant. So there was really a lot of benefit in doing that. But we don't want to just use offsets. I mean, we need to decarbonize our campus in terms of our direct emissions as well. And that is, it's really responsible for that is our Department of Facilities and our Office of Sustainability. And so we're, doing things like when we build new buildings to try to make them as energy efficient as possible. So for example, in my talk, I talked about the nano building. So that nano building, which in order to keep things super clean, there are big air fans that are blowing air. So it's actually a very, very power intensive building. But nonetheless, that building was categorized LEED Platinum. So it is the first LEED Platinum building of its class. So we're, as we build new buildings, with that in mind, we're trying to make them as efficient as possible. I indicated that as part of MIT's investment holdings, there's a parcel of land where there's a Department of Transportation center called Volpe, and MIT won the rights to develop that as a mixed commercial and academic center. And our investment arm has committed to have that be, all the power there be electric, so that there be no fossil fuels used in powering that area. So, we're doing things like that. We're greatly increasing by 5-fold the distribution of solar panels on the campus. A study has done to comprehensively look at what roofs we can put solar panels on, and that is underway. And then, of course, we're also rejuvenating our vehicle fleet, and basically as a nod to the college, also undertaking an AI study to look at optimization of temperature throughout our buildings. So those are some of the things that we're doing. And as I look at my the clock here, we're running short on time, and there's a question here in the chat. How can I participate as an MIT alum and a sustainability professional? Okay, and so that actually is a great tee up to my closing remarks, which I promised you I had a couple of more things to say. So if we can find those, I'm going to share my screen. Okay, so we're accelerating climate action with new resources, and I think if you take anything away from what all of us have said today, is that we really mean business here. We are taking this on, and we're going at it with our heart and soul. And these are some of the things that we're doing. So we're going to be hiring at least 20 new faculty members in climate and sustainability related areas. And that really will both increase our research capacity, but also the numbers and the offerings that we can offer in order to educate our students. We're creating up to 100 new climate and clean energy graduate fellowships. We're offering what we're calling CROPS, Climate or Clean Energy Research Opportunities, so parallel to the UROP program, to every undergraduate who wants one. So consider helping support us on this very important program that we would like to roll out this fall. Here's another area where the alums can participate. Our Climate Action Symposia series was exceedingly successful, had over 12,000 participants in the one that we had last year. So we're going to have a new series that all of you will be able to tune in from and learn from. And then obviously we're elevating climate as a priority in our philanthropy. So you know, it's this is an MIT kind of problem. It's difficult, it's very hard, and it's going to take not only those of us on campus, but it's going to take all of you. As part of our activities, we're going to be putting together a series of working groups. We're going to be putting working groups on education, on policy, and in other areas as well. And we're hoping that alumni may be interested in serving in some of these working groups as well. How do you connect to us? So go to our climate portal, climate.mit.edu, for what I call the 3 Ps. Our portal, podcast, and our primer. So we have Professor Carrie Emanuel of EAPS has a book on introductory climate science. If you want a holistic view of that, we've turned that in. We put a very, very accessible graphical interface there, and it is a Webby winning offering. We have a podcast, Today I Learned Climate, a whole series of short vignettes on different aspects of climate. That's also an award-winning activity. And then just a whole summary of information of other things that are going on campus. So I'll just close by saying here that 2050 is closer than you think. Babies who are born later in this decade will be attending MIT when the 2050 is here. And those of you who were at campus of order of 20 years ago, think back and you realize how fast the time has gone. And so, so we've got to get down to business. We need all of you. And the fact that so many of you have tuned in today has made it obvious that you care about this problem too. So we look forward to working with you in partnership. And I thank you all for tuning in today, for your interest and your support of MIT. And this is the continuation of a conversation and action that we'll all be taking together. So thank you very much.
Thanks for joining us. And for more information on how to connect with the MIT Alumni Association, please visit our website.